Cloud Advisory, and I'm here to talk to you today about cloud security. So the abstract is here. I'm going to focus mostly on how the self-service, multi-tenancy kind of trends in cloud security and the technologies that underpin those trends or fail to underpin those trends impact how cloud security is practiced and how you can improve cloud security by adopting newer technologies with newer operating models that work, that are compatible with DevOps. So first I want to go into some of the problems that we see with our customers as they try to deal with multi-cloud cloud security. So we have customers on OpenStack, Kubernetes, AWS, Azure, so it truly is multi-cloud. I'm going to focus mostly in this presentation on OpenStack and Kubernetes. So it is the Open Infrastructure Conference. Cloud security headaches, so there's studies done every year. Industry practitioners provide their feedback on what are their biggest challenges, and visibility is always at the top of the list in terms of cloud security. Being able to set good compliance policies is close, and being able to actually govern policies consistently across clouds is usually third. But visibility is always number one because the other two depend on visibility. Organizations have found that legacy security tools don't work in the cloud. Some organizations are still finding out that virtual firewalls everywhere is not a viable strategy to moving network security to the cloud. It's kind of taking legacy technologies and putting it onto a new platform in a way that it wasn't meant to be used. But it's not all tooling. There's been this trend in the last 10 years, 5 years, depending on your organization, to move everything towards automation and self-service, multi-tenancy, so that you can get things, developers and other people in the business can get things done without being held up in provisioning. Some organizations are still kind of just running into that. But for me, that stems from SecOps and DevOps not really having the same operating philosophy. So DevOps preaches you have multiple groups of teams, you align their motivations, you align the strategies that they're operating under, you make them use the same tools, you get similar outcomes, and you get better feedback, better ability to iterate, make changes quickly without introducing problems. SecOps hasn't really kept pace with that, so you have different people, different groups of people with different motivations, different strategies leading to different tools and behavior, which is a recipe for failure. That, for me, is why you have the visibility problem. It's not just that legacy security tools can't get visibility into these environments. They do lack cloud context, but it's that you have this old operating model trying to be forklifted into the new way of doing things, which is meant to be efficient and dynamic, which traditional security is not. So as the industry has moved toward automation and self-service multi-tenancy, there's 4 things that have happened. Assets became dynamic, sometimes ephemeral, but at the very least you can provision assets through an API call, so there's nothing that's truly immutable or unchangeable. The second thing, developers started managing security groups. Not just developers, I pick on developers, I am one too. But really it's that people who don't know security policies started implementing security policies. They took that away from the centralized security folks who were getting in the way of business. Third thing, the perimeter disappeared into non-existence. Perimeter-based networking is still somewhat the default. Everything's based on prevention. Prevention of threats coming inbound. Not so good at preventing threats from crossing laterally, but it's still prevention-based, and prevention eventually fails. It particularly fails when your perimeter-based approach doesn't have a perimeter anymore. If you think of AWS, public IPs, floating IPs, and OpenStack, services and Kubernetes, where exactly is the organization perimeter anymore? It's wherever an API makes it available. So there's nothing you can go and physically touch as a perimeter anymore. And last, kind of a summation of the other 3, SecOps lost visibility and control while cloud deployments grew. So they've lost visibility into things. They can't see what's changing, they can't control what's changing, but there are more changes happening all the time. So how do we solve this problem? So Cloud Advisory has its main product, the Cloud Advisory Security Platform, CSP. First, we want to solve the visibility challenge. So how do you gain visibility? CSP connects to cloud provider APIs, so OpenStack, Keystone, Neutron, and Nova in particular. Kubernetes APIs and public cloud provider APIs to integrate natively with the cloud providers. So everything we do is meant to be agentless, automated, automatically discover all the assets, and let you see all those assets from one interface. Second problem we want to solve is that configurations are left too open. The configurations of security controls are in the hands of people who shouldn't be making those decisions often. But you need those people to make the decisions so that they can move quickly. So the secret is to put limits, put guardrails on what self-service can do while still allowing for self-service. Keep the efficiency, but put sensible limits on it so that you don't shoot yourself in the foot with one person not knowing the security context of what they're doing, trying to be efficient, opening up SSH to the world or some other protocol, and sabotaging their own organization by accident. Third problem, so with a lack of visibility comes a lack of ability to know whether you've been hacked or not. I think most organizations still practice security from the perspective of prevention, trying to make sure that the bad guys stay out. Where evidence shows most organizations take at least 6 months to identify breaches that have actually occurred. And that's just the time to detect breaches that are ever detected. That doesn't account for breaches that are never detected. So it's a better operating model from my perspective to approach cloud security from the perspective of you've already been hacked. Find out where. Find that activity that's crossing east-west, trying to pivot to your most valuable assets and extract them instead of focusing on the perimeter, keeping people out, and focusing on policies related to that. So we talk about the cloud security journey. What we find is organizations always lack visibility into their multi-cloud environments. Most organizations want to go beyond just getting visibility into things. They want to set compliance policies, know whether they're in compliance, and base their checks off of some internal standard or some external standard like CIS, PCI, NIST, OpenStack security checklist, and others. Fewer organizations are actually ready to get to automated governance, where you're not just saying, I want to see if this condition is ever true or false, like compliance checks. You want to go beyond that and say, these workloads will always have the least privileged policies that they need to do their job and nothing more. So that's the difference that we make between compliance and governance, is when you're actually explicitly managing the policies. So some organizations want to get to governance, that's their stated objective. They bring us in and they say, I need microsegmentation, I need to get a handle on the security of my workloads because developers have been in control of the security policies for years. And then we get in there and we show them things, they find a bunch of things that they need to fix, and before long they're realizing, we're not ready for governance, like we want to get there. But if you could just do compliance and let the asset owners see when they're in compliance, when they're not in compliance, automate that process of checking for compliance, sending out notifications to the asset owners, that ends up being a good starting point for most organizations. So this is a slide on how CSP integrates with cloud providers along with some of the features that we provide. So integrated risk management, so we're running compliance checks to detect whether desired state matches actual state. When that doesn't happen, when compliance fails, we call that a risk. You can call it a vulnerability, exposure, whatever you want. But we allow you to set severity levels for each compliance check and break those compliance checks into compliance groups so that your production assets can have different settings for compliance checks than your development and QA assets. We do microsegmentation for the orchestration of security policies via cloud APIs. I'm going to show most of these other features, so I'm not going to spend too much time on them. And the last one on there is machine learning. So we actually learn the network flows associated with your cloud assets, compare them to security policies, and provide recommendations for what your security policies should be. So there is a bit of machine learning in there, but it's meant to be useful machine learning. It's not trying to find every anomaly in your cloud and give you an alert for every single thing. It's trying to assist you in building better security policies, improving your security posture. So other things Cloud Advisory allows you to do, identify risk, vulnerability detection. So we can also compare network flows to configurable threat intelligence feeds, so you can see if there's any connections from your workloads to known threats. And it's actually somewhat common for Cloud Advisory to go into like a POC engagement. Customer configures credentials for their cloud account or accounts. A couple of minutes, we have all the asset data, and a couple of minutes later, they see, hey, what's this connection to China? What's this connection to Ukraine? That's not supposed to be there. This is a production workload. So what this slide is showing, this is a screenshot from our product. This is one particular page that was, this feature was created for a large telecom in the US that had a team of people, 7 to 10 people basically working normal business hours, but that's all they did is query security group rules across dozens of OpenStack accounts. And they were never actually getting through all the security group rules. They were only looking for certain rules they didn't want to see, like SSH open to the world, Memcache open to the world, insecure protocols, FTP, and things like that. They weren't checking for the quality of the security group rules, and they were never getting through everything, sending manual notifications, and they realized that was a critical problem. So what we did with this interface is allow you to view all your security groups, all your security group rules across all of your clouds, whether it's AWS or Azure or private cloud things like OpenStack on Kubernetes. Sorry, they're called network policies instead of security groups. But viewing all those rules across all your cloud providers from a single interface, having a query interface where you can build out, I'm looking for this protocol coming in this direction, this port. You can even search on which account it's in, certain tags. If you say a tag is EMD prod, any tag you want to put in there, you can search, generate a query, define security group rules of interest, and then you can save that query as a recurring compliance check to say, I never want to see this happen, alert me if it happens, or alert the asset owner if it happens. Automatically take the metadata associated with the instance and figure out who I need to email and send the email to the asset owners automatically when there's a compliance failure. Or go a step beyond that and say, I never want to see this, and if you do see this, you need to remediate it. SSH should never be open to the world. If you see a security group rule that allows that, just fix it automatically. Kind of an intro to governance. All that's very doable through this user interface. Create a query, save it as a compliance check, customize how the compliance check runs for different parts of your infrastructure. Everything we do through the UI, again, can be done through the API, so it's also an API function that you can use to create compliance checks for network security policies. We do network security policy compliance, I think, better than any other competitor. All our competitors have compliance checks for CIS and NIST and PCI and GDPR and all those things. So we have 1,200 or so out-of-the-box checks right now. It grows all the time. What we found is that customers usually want a fair percentage of that out-of-the-box, of those out-of-the-box checks, but they also want to create their own checks. Every customer always has some custom needs. Most customers, that may even be the bulk of their requirements, is a long list of things that need to be checked for that are not a part of a standards body. So we have a pluggable, extendable compliance framework written in Go that can be used to do any type of check against any standard you want anywhere. I'm going to show some of this stuff. This is just the dashboard for CSP. I'm going to do my best to get through some of these things and get into some demo stuff and leave time for questions. So this is just an example of a compliance report for AWS, CIS AWS Foundations benchmark. A couple of examples for Azure. It's just basically going section by section for the standard and seeing which compliance checks apply to that section or to each section. We also have the ability to allow the customer to create their own compliance checks for their own needs based on any standard. It doesn't have to be a published standard. They can name the compliance report, whatever they want, and map compliance checks to particular line items and produce their own reports that way. This one, OpenStack compliance report. This is actually based on the OpenStack security checklist published and maintained by the OpenStack community as part of the OpenStack security guide. So there's lots of tools you can use like Ansible OpenStack to make sure that your deployed configurations are actually compliant with the OpenStack security checklist. This is the only solution that I know of that can actually take that functionality of making sure things are in compliance and make it so that security practitioners can actually see that. It's fine if your DevOps team can provision good policies for OpenStack. It's another thing that security practitioners can actually audit that, right? More kind of marketing slides about cloud API integrations. I'm going to spend a lot of time there. Another differentiator we have in the market is the ability to process and visualize network flows. So what you're seeing on the right side of the screen there is multiple cloud providers connecting with workloads connecting to multiple workloads. This is how we do network visualizations. You can map flows to the workloads automatically, and then the color of the lines determines whether that was applied, that connection was against policy or with policy. So green is good, red is bad, gray is unmanaged. And we allowed you to orchestrate microsegmentation in two ways. Again, Cloud Advisory's platform is going to communicate to the cloud provider APIs directly and orchestrate those policies, but we can do it either taking your existing security group rules and treating them as golden, we call that golden state microsegmentation, or by orchestrating the application of security policies based off of metadata. So for every workload, we can automatically tell you what provider it's in, what provider account it's in, and depending on the cloud provider, we can give you other data, like in OpenStack, we can tell you what project it's in. In Kubernetes, we can tell you what namespace it's in, what pod the container's in. Any of that metadata, including tags that you set on instances, can be used to set policies. So you could have a default policy for anything in a given OpenStack account that says anything in this account has a default outbound policy that allows outbound to accepted DNS servers, accepted NTP servers, and that's it. And then a different default policy for the project level that says anything in this project can then access these more sensitive resources, and then workload-specific policies if you want. All right, no more slides. Let's see if I can mirror my display for a second. Okay, I'm going to show a couple of videos because I don't have a few things set up in the demo environment. I'm going to try to do a live demo if the network gods will approve it. Actually, I'll come back to the dashboard in the live demo. So OpenStack infrastructure visualization. So what we're showing here is the network flow visibility. So we'll transition from the dashboard to the network flow area. You can see the different networks, and then there's an icon for each cloud provider type. So AWS, Azure, Kubernetes, and then OpenStack, there's two accounts shown here, what we call Dev1 and OS2. So if we drill down on one of those accounts in particular, it's going to expand out a bunch of things. And all those little objects that are hard to see right now are projects within OpenStack. So this outer line in the visualization is the provider. So OpenStack is the outer line. The inner line is the project, and then if you drill down again, you would see the workload. So we kind of add a line to the outer ring to match the taxonomy, the hierarchy of the cloud provider. So on AWS, you would see the AWS, you'd see the account, the VPC, and then the workload. Kubernetes, you'd see the Kubernetes like a cluster, namespace, pod, container. And just one more thing to draw attention to in this visualization. So I talked about getting metadata automatically for workloads. So on the right side there's an attribute section and a metadata section or a tag section. So attributes are things you get automatically for all workloads in a given provider. Things that are guaranteed to be there, like you know which account it is, which project the workload is in. Tags the user has to set, and we have the ability in CSP to say, you can base a policy based off of this metadata, but there's a gating step that has to happen where someone from SecOps has to come in and actually approve the application of the policy. Hopefully this HDMI connection holds out on me a little longer. And I'm going to transition now to, this is actually a demo environment for our product. So this main screen. This dashboard is meant to be dynamic. It's inspired by things like Kibana, where you can use filters to drill down on what you care about. So you can see everything at a glance, use filters, drill down on what you care about, and then pivot to a more specific interface. So if I were to come in here and say I only want to see provider is OpenStack, you see the risk score updates, every number on the dashboard is updated automatically based off of the filters. So we're only seeing risks for OpenStack. That way you can see risk aggregations kind of by providers or provider accounts. And if we open up the OpenStack area, you can see critical, high, medium, and low risks. These are compliance failures for discovered OpenStack endpoints. Sorry, I didn't mean to click on that. One other thing to open up here. So you can do the same thing, critical, high, medium, and low risks grouped by different attributes. So here grouping by the service attributes. So we have Horizon, Cinder, Keystone, the different OpenStack services that we support. It's not necessarily showing all the OpenStack services that we have compliance checks for. It's showing all the ones that have compliance failures. So you're not going to see things in here for an OpenStack service if there's no failures for it. So for example, if I were to click on any one of these things, I'll click on Nova. It transitions me to a more specific interface. It creates 4 filters for me, and it checks a box up here for distinct result. So what I want to show here is the value of having the ability to drill down, because if you were just coming in looking for particular failures, in fact, let me add one more search thing to say I'm just looking for severity is critical, and I just get one result. And say that was the thing I was looking for, and now I can open up the line, figure out what's going on here. I can see which workloads passed, which workloads failed, and from here I can choose to remediate or remediate and notify. Again, where notifications, we can actually pull the notification list from metadata. But if I remove filters, kind of going backwards, instead of 1 result or 5 results or 30-something things to look through, if I remove all those filters, I have 816 distinct results to sort through. Distinct results meaning the most recent current state. If I remove distinct result, I've got 14,000 things to look through. And this is a very, very small environment. So you can see how it's important to be able to have the ability to see everything, but not get lost in the process of seeing everything. A couple other things. So I want to jump to compliance reports. Let me take one step back first. Compliance groups. So I said you can group the settings for checks based off of compliance groups. Compliance groups are just kind of groupings of cloud provider accounts. So you can see this prod eng has 2 accounts. And I can set settings here at the group level that will apply to all checks unless overridden. So I can set a default severity, a default person to notify, default auto remediation behavior, and then each check can customize those settings. The checks also come with default settings based off of the actual severity that we estimate, but that can be easily customized. For each compliance group that I was just showing, compliance groups, you can view reports for compliance. So you're only going to see reports for assets that make sense for assets you actually have in that compliance group. So in this particular compliance group, I have AWS and Azure. So you see the possible reports for AWS and Azure. So AWS CIS, GDPR, PCI, HIPAA, NIST, and the same for Azure. Again, section by section, all this can be exported PDF, XLS, Doc, or CSV. But to show for OpenStack, since that's where we are, here's basically the OpenStack security checklist turned into report format, where we're going through the checklist section by section, identity service, so basically Keystone, Horizon, Nova, and just going section by section. So you can secure the actual underlying infrastructure for Kubernetes and for OpenStack, and we can secure the VMs and the pods and other workloads that run on top of those clusters. All right, I want to show just a couple other things, and I'll open it up to questions. Again, I don't have a lot of network flows in this environment, but I at least want to show this visibility interface, where if you click an icon, it drills down. I'm just looking at Kubernetes. There's only one Kubernetes cluster called kubedemo, different namespaces within Kubernetes. And then you can actually see the pods that are actually generating traffic. And all the lines are gray because we're not actually managing policies for this. This makes it very easy to see flows that cross logical boundaries, like flows that cross accounts, cloud providers. Very easy to see in this interface when those flows cross those boundaries. And then you can actually go to, click on a given workload to view connection summary. And then we have the entire network flow history for this workload and all the workloads shown here that you can search from here. So you could put in any particular thing that you're looking for, like a specific IP, a port used in the network communication, tags, anything else, and actually do an audit or a drill down into the event history of these workloads. You can also create network groups so that you can map flows to, if you have flows that go to things that aren't in OpenStack or aren't in a monitored cloud provider, then you can create networks here, and that way the visualization will actually map those flows to networks of your choosing. So you can put in custom CIDR ranges here, and those will show up in the visualization. Network policies, there's hardly anything here. This is where you actually map. Yeah, I should have shown a video for this. There's nothing there right now. We're not using that in this demo environment. And network security this is basically the golden state microsegmentation, where we're discovering security groups automatically, and we allow you to basically preserve those security groups over time while providing recommendations to say, this security group really needs this rule to be added or this rule to be removed and replaced with a more restrictive rule. So I don't know if I have any recommendations to show right now. So this is another way to show recommendations of basically machine learning determined that this /28 should be added to allow TCP 8080 for this specific workload. And you can see the actual security group rules that are already there. So it makes it very easy to build out secure, least privileged security group rules by leveraging machine learning. All right, I have a lot more I could show. I'm going to open it up to questions there. Sorry, can you use the microphone?
You mentioned about micro-segmentation. Mm-hmm. So when the kube pods are auto-scaling, will that micro-segmentation policies be still applicable?
Yes. So the question is, when Kubernetes deployments are being scaled out, when the number of pods or nodes in a given deployment are being scaled out, will the policies go with them? Will those still apply? And yes, actually, Kubernetes is actually a really good use case for the tag-based microsegmentation or metadata-based microsegmentation, because everything in Kubernetes is based on labels, which is tags, metadata, right? So as things scale out, new workloads come up, Cloud Advisory automatically detects that, and the network policies are automatically associated with those. Okay. Can I answer your question?
Yeah, thank you.
Okay. Any other questions? All right, we'll call it there. Thank you for your time.